What did the Hugging Face, number one moment unlock?
We didn't even expect this to happen
Yeah.
this big, because if you launch something which is somehow contrarian to the transformer, to the current norm, we're expecting, maybe people thinking, oh, it would be exotic. What happened is that the paper started trending on Hugging Face, and we got very excited research community. And the timing apparently is right for this, because so many people were kind of waiting for this to happen. And I think this is the main feedback, just, emotional. It's like, oh my God, finally. As if, there was this kind of a balloon of frustration or doubt and something that was, growing. All of a sudden we're like this first needle that went into it.
Welcome to the EU Startups Podcast. Sit back and enjoy the show hosted by Marcin Lewandowski.
Hey everyone, this is Marcin Lewandowski and you're listening to the EU Startups Podcast. Today I'm with Zuzanna Stamirowska, complexity scientist and CEO of Pathway. After years of frontier research, Pathway launched a post-transformer reasoning model that trended number one on Hugging Face. It tackles the big three enterprise blockers: black box reasoning, limited context, and fine-tuning hunger, while slotting into modern stacks without rip and replace. And it's already used by teams at NATO, Poste, and Formula One. Zuzanna, it's such a pleasure to have you on the show. I'm pronouncing your name and surname so easily and so perfectly because I'm Polish as well. Welcome.
Hello, thank you so much for having me.
Awesome. So, Zuzanna, for those who don't know you, who's Zuzanna Stamirowska and what Pathway is all about?
So I'm the co-founder and CEO of Pathway. As you said, I have a background in complexity science. And Pathway is pretty much making machines think and adapt like humans.
Amazing.
This is what we're after. We're actually driving right now the shift in AI. Maybe, right now, when you look at this, every model feels a little bit the same because they kind of really are the same. They're all based on the same basic architecture, which are the transformers. And we see that transformers are showing some cracks. I mean, they're not behaving like us, right? Yeah. And if I were to tell you that intelligence should be more adaptive and more in tune with the environment, I mean, this is a no-brainer. It's kind of very natural, and it's fundamentally not how transformers work. And we start to see also, limitations in terms of not enough data in the world to actually satisfy the training needs. We start to hear, maybe you guys read some reports by Bain, that there is, not enough energy in the world to power all the AI demand that we're having around the corner. Yes. So there are many cracks, let's say, and it's time to have a new algorithmic innovation that will, lead the next stage. And this is what we're proposing at Pathway and what we are about.
Amazing. That sounds super exciting, Zuzanna. So I can imagine you're very excited every day going to work and working on this future of the world. Starting line, maybe I would start from this question. As a complexity scientist, what did you see early that told you we need new AI foundations? Not bigger transformers.
Yeah. So I mean, coming back to what I just said before, right? If you want a useful system, it should usually be somehow linked to the context and the environment that it's working in. So we do want to have a more dynamic, responsive AI systems that would be really useful. Right? That's kind of it. But this means they would function a bit more like us, a bit more like a brain. And in complexity science, we study evolving systems. So evolving systems mean that from local rules and interactions between kind of small particles, we see global phenomena. So we model these rules really, and then we manage to contain chaos in a certain way. And we often say in complexity science that there's no hurricane in a single drop of water. and the entities are little drops of water. Or we would say that there is no financial crisis in a single dollar bill. And what we see, in fact, like with LLMs, with transformers right now, is that the notion of time is fundamentally missing from them. So they're static by definition. And now, to have this kind of evolution I was saying before, something being created, evolving, I mean, you need to have evolution in time. I mean, there is no way you could deal with a large evolving system without having a notion of time. And then the second thing is that if you look at AI shift as a whole, and you maybe talk to some investors or like hedge funds, you will see that it's a shift which is so profound that it's almost like no other. Yeah. People are trying to draw parallels to the internet, maybe electricity even. But it's very hard to draw these parallels. So what people are doing instead is that they're trying to identify main driving blocks that will be, like parameters that will be driving this change. And one of them is memory. And the topic of memory right now is missing from LLMs as they are mathematically built. We can have weights, but they're trained once, right? And again, it's not a memory that happens, that is formed over time. And this question of memory can be addressed from two sides. One is hardware, of course, and we see everybody working on this. So NVIDIA is launching Blackwells. We have new generations of chips. Everybody's working on some sort of custom silicon. But the second part is algorithmic. Can we have a smarter way of learning? One that would be infusing, time and memory into LLMs. And what we are bringing actually with our architecture is native memory.
Amazing, Zuzanna. You're talking about so many amazing and complex things here. For those, because we have our audience is broad. People are generally interested in these topics, and some of the questions that I'm gonna ask you are gonna be, kind of exploratory for us to understand better. So this is all amazing what you just told me, and I wanted to ask you if you could explain, like a post transformer in one sentence. Like, what core limitation are you discarding first?
So this is exactly what I just said. The core limitation is memory. And then memory is linked to time. I mean, right now, transformers are static. They're trained once. So to break it down, we have something that's called pre-training. Generally speaking, transformers are trained, the weights are formed, and we keep on hearing about larger and larger models with like trillions of parameters, and like entire internet being fed into it. This is how the architecture, let's say, this is how the models are trained right now. And then they're launched, and then they have serial numbers, right? We have GPT-4, or we have GPT-5, and like same for Llama, same for everybody, because they're like, these are iterations, they're like formed models that are trained once.
And I was wondering,
tell me. So they're static, and we're bringing dynamism into the way really attention into the way the models learn.
Amazing, Zuzanna. How does Pathway, adapt midstream when new evidence appears? What changes inside the model?
Of course. So first of all, this model, this architecture, so the Dragon Hatchling or the BDH architecture, functions a bit like a brain. So you may imagine that there's like a network of neurons, and neurons have connections between them. And connections in the brain between neurons are called synapses. And what happens is that whenever you hear a new word, like the model, let's say, hears a new word, this signal will work like a signal in the brain. I mean, we'll have neurons propagating, this signal in the network, and synapses that care may actually strengthen, so they'll become stronger. This gives this dynamic element of learning and attention that we have in BDH. But then for reasoning itself, there are like other steps that happen in post-training of models. And this is something that we're currently working on, and probably will be subject to the next announcement.
Amazing. Zuzanna, I think your headphones stopped
Yeah.
working because, yeah, awesome.
Is it all right if I just, because I think they might have died for some reason.
Okay, okay. Hey, Zuzanna, amazing. Another thing, what does visibility look like in Pathway? Because like what can users kind of inspect or export to trust how conclusions are formed?
Yeah. So in the short sentence, BDH gives native interpretability. So if you compare it to the current transformer architectures and all the research which is related to interpretability, for example, Anthropic is very good at this. I mean, folks are trying to get like brain scans, to see what's happening inside, and they are literally kind of constructing the equivalent of MRI, so diagnostics machines, let's say, to see what's happening in the brain and the model. And this is kind of very tricky. So plus the interpretation of attention mechanism in Transformer is not very intuitive. And in BDH, you may imagine that you kind of have a camera inside the brain and you always see what's happening. It's like as if you had a CCTV of what your brain is doing. And plus we fully understand the attention mechanism. So what you see is you actually see the neurons and like the synapses that fire up when a given context is mentioned, when a given word is mentioned. In the paper which we published, we actually showed the example of synapses that fire up for the notion of currency and in the European Parliament, which is actually a funny example of a training data set.
Amazing, Susanna. Let's talk context, without bloat. Like, how do you keep long range context alive without exploding latency or cost?
Of course. So, I mean, this goes back to architectural changes, and in fact, in part, this is why we have needed a fundamental change to the architecture. So, our architecture BDH has a very large but fixed working memory, and your memory is defined this memory is defined by the number of neurons in the brain, in a way, by the model size. And this is just how much you can stack in it. And this allows us to keep a lot of information in context and even skip irrelevant context, but then also calling everything in a very efficient way.
Amazing, Susanna. Your answers are so spot on, and so so I just never know whether you want to expand a bit more or this is it. But this is amazing. I love everything that I'm hearing so far. Why does Pathway need far less data to specialize, and what's the kind of Monday morning for you, good morning setup for a customer?
Yeah, sure. So you need less data because you kind of learn contextually. I mean, this is a different mechanism of learning, if you wish. The job of this model, so it's not exactly, we're not even exactly competing in the exactly same use cases as the large current LLMs are playing. We're looking more for sticky inferences, like more enterprise process aware type of questions. So you have way less contextualized data and this plasticity that happens at the connections stage. And the goal of the model is in fact more in the post-training phases and in the adaptation and reasoning that happens and following steps, as opposed to forming, let's say, weights at the beginning. And this means that the job of the model is to learn patterns of reasoning and keep on learning them, as opposed to forming, a huge, let's say, database of connected facts. And this gives you an intuition, hopefully, on like why we need way less data. This is hyper contextualized. Only the relevant data is being used.
And Susanna, speaking of use cases, let's maybe talk a bit about field proof, across NATO and La Poste, Formula One. Is there like the shared operational pattern that made post transformers necessary? Like, how do you?
Yeah.
Can you give us some example?
So, I mean, as I mentioned at the very beginning, right? We need AI which is more in tune with the environment. And if I can borrow a very nice catchphrase from NATO, I mean, the topic is situational awareness. If a very complex situation, happening in real time, and you're trying to piece it all together and ideally come up with next best action, right? This is something you would be obviously doing in defense. This is something you're doing in any kind of large processes that happen around the world. Hence, La Poste. You also do it, let's say, maybe at larger scale, but at way more critical time scales. You also do it with Formula One or like critical applications where latency is key. Now, I would like to specify that the model is about to be launched, and these customers that you're referencing right now, they're actually using our technology, which is a precursor to BDH to the live models.
Okay.
But of course, this is why we came. Why we knew we needed to build a post-transformer architecture, why we needed how we knew we needed to develop in this direction, because we actually got a very strong signals from the market. And right now we are working with a couple of design partners, which are not mentioned here, to deploy the model trained on BDH.
Amazing. Zuzanna, I know that you have like a team of rock stars working with you. And I was just wondering, like, if you put so much talent, so much technical talent in one place, you have how do you make researchers and infrastructure gurus and community champions kind of ship together?
Yeah. First of all, you keep the quality. Let's say if you have an A-star, A level team, right? You kind of have to keep the level A team, A level. So this is important because everybody's happy that they, at least the people who work with us, they don't necessarily have big egos. They're actually happy that they are able to learn something from their peers. So I'd say this is one. Second is that, well, there is quite a lot of tie breaking, but this is my job. And I think over time it's trust. We've been working for a long time together. We've seen each other through the good and the bad and the tricky and everything. But at the end of the day, we have different perspectives, different backgrounds, and it's in this diversity that we're capable of actually bringing something completely new. Because if you just have copies of the exactly same profile, then you will just the innovation would just be iterative. So this is even visible in our research and like in our breakthrough, where we actually use perspectives coming from different disciplines. Some intuitions from complexity science that I described at the beginning, but just like the lead researcher on the topic, Adrian is actually also a quantum physicist and a theoretical computer scientist. Jan, our CTO, worked with Jeff Hinton, so he comes with all the story of like how attention was invented, even at the very beginning. So he has this like very deep intuitions. So it's all of this coming together that makes a difference, because then we can spot, okay, where perhaps history should have taken a different turn, as opposed to staying in one lane that everybody's swimming, right? And kind of jumping in the same or hitting the same obstacles.
Yeah, it makes total sense. It's nice to have, to be surrounded by like-minded, smart people. But actually, yeah, I totally agree. And like the true innovation happens, when you have this like different points of view, diversity, and like there's this friction, and it just happens on the edges. So amazing to hear that. I know that I think when I was doing research for this podcast, like one of your team members, like he's got his PhD when he was 20. It's crazy. It's amazing team. Congrats, guys, on that, and keep going. And I think another thing that I think you didn't mention, but it's so obvious, like the goal that you're going towards together with the team, and like that it keeps them motivated and interested, and so like fired up about going to work every day and like working towards this. I think is also quite a big factor of like keeping everyone happy.
Yeah, of course. I mean, we are after generalization over time. Generalization over time is like the topic of generalization, really. It means that instead of repeating things that existed, you can actually create real innovation, right? This is what we're after. And this is what seems to be one of the last big missing bits in AI on the way towards superintelligence. So yeah, it's worth waking up in the morning.
Come on, this is so good. I love it. Zuzanna, did did that the fact that you got you guys had this moment, or maybe let me reverse the question. Like, what did the Hugging Face number one moment unlock? Like, did it help a lot to be like an open number one at the open source there? Like, did it help like attract talent, feedback loops, or enterprise pool? Was it any?
Yeah, you know what? We didn't even expect this to happen this big, because if you launch something which is like somehow contrarian to the transformer, to the current norm, like we're expecting, maybe people thinking, oh, it would be exotic. Well, no. What happened is that, the paper started trending on Hugging Face, and many beautiful things happened. Mostly, like, we got very excited research community. The timing apparently is right for this, because so many people were kind of waiting for this to happen. And I think this is the main feedback, just, emotional. It's like, oh my God, finally. As if, there was this kind of a balloon of frustration or like doubt in something that was, growing. All of a sudden we're like this first needle that went into it. So something bursted, and like people started like way more openly discuss the fact that, okay, there are all these issues that we need to address. We need to be more efficient. And, our inferences can be like 90% more efficient. We use 90% less compute per output token. I mean, this is huge. But this is a fundamental shift. And then you need to say, okay, maybe the king, well, it's not naked, but the king perhaps should be already replaced. And I think this was just amazing. And then, of course, like, there is the entire AI community, people drafting blog posts about us, people organizing meetups that we don't know of, in the Valley. And it's just amazing. And then, of course, like everybody else, customers reaching out, asking, hey, when can I start using it? Because I struggle with this and that, or this or that. I need long context that I can use efficiently. I have scarce data, etc. So yeah, absolutely amazing. All the partners also came together, because we have like strong partners, NVIDIA and AWS. So of course they're also excited. Well, I'd say it had to be done, right? We were like happy we disclosed it, and I just can't wait to see all the consequences that will happen in the scientific community as well.
Amazing.
Yeah.
So exciting, Zuzanna. Let's talk about, I don't know, maybe 12 months, like actually at the speed that everything is moving, 12 months is probably a long time. And sometimes, like some may say, even that is hard to predict. I know it's like definitely hard to predict what's gonna happen in like 5-10 years, but maybe let's talk about the next 12 months. What's your vision, and maybe one capability you're most excited to ship, and what door it opens.
I mean, for us, it's definitely generalization over time, and we'll be going after it, progressively. But right now, GPT-5 is known to be capable to focus on, to do the equivalent of 2 hours and 17 minutes of focused work of a human. And, extending this is the goal. And at a certain point, we'll get to superintelligence, but this is like a very nice metric to keep track of, because the longer the task, the more complex things we can accomplish.
Nice. Do I hear, like, is there a very unhappy cat?
Yep. Sorry.
This is amazing. So the cat is not agreeing with you. It seems like, I don't know what's happening there, Zuzanna.
No, I think he just wants to enter.
This is amazing. Okay, so this is, I don't know, do you want to add something to it? Or should we?
Generalization over time. I
Okay,
hope we get there within 12 months.
okay, nice. Awesome. Sounds great. Zuzanna, this is a time during the podcast when I usually play a little game with my guests. It's like rapid fire. So rapid fire questions, fast answers. Are you up for playing?
Yep.
Okay, let's go. So this is the first question. Human thinking trait you want models to emulate next.
Generalization over time.
There we go. We stick to this one. Metric you value more than parameter count.
Time focused on like success, the meter metric. So time focused on a task, let's say.
Okay, nice. Benchmark you'd retire tomorrow and why?
Needle in a haystack. Although I don't have any benchmarks I don't like.
Okay, that's nice. A failure mode that taught you the most.
I don't know.
Okay, that's fine. That's good as well. Person you'd swap jobs with for a day.
Nobody. Sometimes I would like to be Adrian, our CSO, just to see how his brain looks like on the inside. But other than this, I love my job.
Nice. And okay, so actually, here's an extra one. Since you mentioned how much you love your job, if you weren't doing Pathway, what would you be doing?
Similar thing, but probably for energy.
Okay. Nice. Zuzanna, last one. Finish this sentence. The future of AI is context aware, not
static.
Okay, amazing. Zuzanna, thank you so much. This is it. I love the conversation. I hope you had fun. I'm sure people will love it. Thank you so much for taking the time and joining me on the show today.
Thank you so much. It was great being here. Thank you so much for having me. It was fun.